I think our next presentation is also a recorded one. This one is by Andrea Zonka on deploying Kubernetes and JupyterHub on XSEDE Jetstream.
Hi everyone, I'm Andrea Zonka from the San Diego Supercomputer Center. I'll be presenting the paper Deploy Kubernetes and JupyterHub on XSEDE Jetstream for the Gateways 2020 conference. First of all, I want to thank Catherine Lawrence for organizing the conference. It's a great pleasure to be part of this community and this conference every year. The link to the slides is available here on the first slide. And this work is a collaboration of different people across many institutions. So first of all, of course, me and Bob Sinkovitz at the San Diego Supercomputer Center. And then most of this work originated from ECSS consultations. So when you apply for a location on an XSEDE supercomputer or cloud resource in this case, you also get assigned, if you want, a consultant that can help you out. So I started collaborating with Richard Signal and Julius Chastang as part of this collaboration. This brought to this work. And if you want to know more about ECSS, here is the link. And also, I got a lot of support from Jeremy Fisher and Mike Lowe directly they are part of the Jetstream team. And as I was a bit pushing the frontier on what was done on Jetstream, they helped a lot making this possible. So the objective of this work is to provide Jupyter Notebooks to a large number of people. So we want to allow people to just be able to access a computational environment with pre-installed software and with significant amount of resources just by logging in through their browser. And this is suitable for a class, a workshop, or for a scientific collaboration, or for just any community. And fortunately, the Jupyter team has already a project which is doing this, which is JupyterHub, that allows multi-user access and handles authentication, monitoring of all the single-user sessions, and so on. And we want everyone to have enough memory and enough computing power. And so we cannot deploy on a single machine. We need the distributed system. And of course, it's more complicated. And also, what we want to do is we want to make it easier for US academics to be able to deploy this. And US academics a lot of them are already familiar with XSEDE, so they can apply for an allocation. And in particular, they can apply for an allocation on Jetstream, which is a cloud resource, very much like the Amazon, Google, and Microsoft clouds, where you can request an allocation. And with that allocation, you can spin up virtual machines in the cloud, and then you have full control over them. And also, we, of course, want to have a system which is automatically resilient and then and can provide additional functionality, for example, logging, monitoring, and so on. And Kubernetes is a great system to provide this. And also, so the allocation on Jetstream is free, but of course it's limited. So we want to make sure that we are not wasting resources. So we want to use our resources just when needed. So we want to be able to scale both manually. So for example, you want to be testing your deployment with very few instances and then scale up when you actually have your user coming in. Or even better, you want to do automatic scaling. So when there are users connected, then there is more requests, you scale up, and then once user disconnect, you can scale down. And fortunately, to achieve all of this, we are standing on the shoulders of giants. So we have the Jupyter team also provided this Zero-to-JupyterHub project, which provides a cloud-agnostic recipe to deploy JupyterHub. And so this works on Amazon, Google Cloud, and so on, and has extensive documentation. And this allows you to install all this complicated distributed system on top of Kubernetes. But first, we need to have a Kubernetes running on Jetstream. So in this paper, what we do is we give an overview and motivation of why you would want to deploy this and how the architecture works. And we provide an introduction to actual step-by-step tutorials. So we have step-by-step tutorials that are available on my website, and where people can follow these instructions, get all the configuration files that are needed to easily deploy first Kubernetes, and then on top of Kubernetes, have already a functional installation of JupyterHub through a custom configuration for Zero-to-JupyterHub. Let's take a look now at the architecture of the system. So first of all, we have some virtual machines on Jetstream. So on Jetstream, it's a cloud resource, so you can either through a web portal or through the command line, and this is what we will be using to deploy this. We can request virtual machine with a number of CPU, with some specific amount of RAM, and this is distributed across the Jetstream system. And on those virtual machines, we can deploy a Docker environment. And so we can imagine we have these Docker environments on the different machines. And Docker allows us to deploy containers so that we have a lot of flexibility. We can deploy, for example, if the virtual machine is running Fedora, we can have containers having Ubuntu or any other Linux distribution. And now those Docker environments are independent. So what we do is we install Kubernetes, so that Kubernetes installs different services across the cluster to basically manage in a easy way all of these distributed systems. So we can deploy containers somewhere in the cluster using Kubernetes. We can monitor them, look at the logs, and make sure that each container has a preset amount of CPU and RAM resources. And then we have, of course, this on our administrative system. We are able to manage all of this remotely with a very clean interface. And once we have Kubernetes, we can set up services to run on it. For example, we want to have a web server, so NGINX is a web server, and we can have it deployed as a container somewhere in this cluster of machines. And then a user can connect with their browser to this cluster of machines and have web page served. Okay, and we can have, but this same container could run on a different machine, and Kubernetes handles all of the internal networking. So basically gives you an abstract interface where you can handle those resources without having to worry where those resources are actually running. And so using this and following the tutorial that I'm presenting here, you can first deploy Kubernetes on Jetstream, and then you can deploy JupyterHub. So once we have a full JupyterHub deployment running, what you have is you have your JupyterHub instance, which is running, and whenever a user connects with through their laptop on this instance, they are redirected for authentication, and this system can easily support Google, GitHub, XSEDE, or even CI logon, so you can use your institution credential to log in. And then the users are redirected back to this instance, and a single user instance of the Jupyter Notebook is started as a container somewhere in this cluster, and each user is assigned a number of CPU and an amount of RAM that they can use. And also we automatically handle persistent volume for them. So Jetstream allows to create on the fly specific volumes for each user, and so we mount those volumes where the single user notebook is running, and once the user logs out, this volume is automatically unmounted, and then whenever the user logs back in, this volume is mounted on another instance where they are running this time. And so we have multiple users that can use this interface, and it's very easy for them, because they basically just see the notebook running inside their browser, so they don't they have no vision on all the complexity of the architecture beneath this. They just have the simple Jupyter Notebook interface that they would see if they were running on their laptop, but now they have all the power that we can give them, and they have a centrally managed software environment, which is very powerful. And we can also, this system also supports auto-scaling. So what happens is that if some users log out, and we have some workers that are not doing much, so there are no user instances, that we are basically wasting resources. So once we deploy the autoscaler, those empty workers are automatically decommissioned. And whenever there are new users that log back in and there are not enough resources across the cluster, then we can create new nodes and have them attached to the Kubernetes cluster. And on top of this, we also have several other tutorials. So we have, of course, we want to set up auto-scaling, and then we have other things that you can take a look at here. I want to just note, for example, deploying Dask gateway is really interesting because you can deploy Dask so that on top of using your single user Jupyter Notebook, you can connect to other workers that are running Dask. So you can use distributed computing inside Kubernetes. We have deployed this in real-world situations. So the largest deployment as of now was done by Julian Chastang at the American Meteorological Society meeting in 2020, where he deployed 40 virtual machines and had 130 students go through a Python workshop on this system. And then he also deployed a lot of systems for classes, and then you see there are other applications below. So thank you very much for following this. So at this URL here, you can find links to the step-by-step tutorials, to the paper, and also to a 1 hour long tutorial that goes more in depth about this. And if you want to try one of this and you find any issue, please take a look at this repository where you can open a ticket.
All right. Well, that was a really interesting talk. Thanks, Andrea. And I know you've been answering questions here in the chat, but I'll just go over them real quick so people have a chance to do if they have any follow-ups on that. So Lance initially asked what were the resources assigned to each session. So essentially each Jupyter Lab session that's set up for a particular, I think, set of users or for a particular use case. And then, I don't know, Andrea, do you just want to briefly talk about it? You can unmute and talk about it.
Yeah, I can just give a summary of what we were looking at. So the idea is that we want to configure, have the user being able to configure their job. So if they want more or less resources. And there are different ways. So if we are on Kubernetes, as in my tutorial, then Spawner has support for that. So it's very easy. You just define a few different configurations, and then the user can choose when they after they log in, they can choose from a drop-down menu, basically. And there is a screenshot linked here. So if you want to take a look at how that looks like. And otherwise, there is a dedicated spawner, which is called wrap spawner, and that basically works. That it's even gives you actually more flexibility. So you could have different kind of spawners so you not only you can choose between different resources on the same type of spawner, but you could have different spawners running at the same time. So you could have, for example, a spawner that spawns a job on a supercomputer, and instead a spawner that just runs locally, for example, if you don't need that many resources. And then you can wrap them with wrap spawner so that the user can choose whether they want to go to an HPC node or just run locally.
Okay, got it. Thanks. I think we have time for one more question. Okay, let's see if I don't see any new questions here in the chat, but I'll ask one. So this was just bare bones JupyterHub, right? So if you're using, so maybe for in the NCAR case, maybe you have like a couple of GIS libraries or something that need to be loaded in to the JupyterHub. So how do you, what's the best practice there for including maybe like, do you have like different kernels for the specific science libraries, or how do you incorporate that into the installation?
Yeah, so one of the configuration options for JupyterHub is the container where the users want to run. And so that's the easiest way. You customize the container. And so you can have all of your software packages, and then you can also have JupyterHub check if that container is updated so that you always have the latest version of that. And another option that I've explored is to use CVMFS, which is a distributed software distribution tool. And so with CVMFS, you can basically have a kernel which is running through CDMFS. And so that you basically handle out all the software environment to CVMFS, and so you're not maintaining that into JupyterHub anymore. So whatever you're doing for other users for HPC centers, you can also use inside JupyterHub, and I have a tutorial on that. I'm gonna paste it into the chat.
Awesome. Well, thanks, Andrea. Unfortunately, we have to move on to our next presentation now, but we can get to more questions again in the last 15 minutes.